Hello all, in this video we are going to solve question number 3 under expression evaluation in JNTU R18 C language syllabus. For that what I'm going to do is I'm going to go open my terminal and navigate to desktop. There I'm going to create a folder called EE expression evaluation question 3 and I'll navigate there and then open VS Code in that location. Now my VS Code is opened. I'm going to create a file and name it as prime number.c and copy the question here. Okay, and how to write a C program and the main function and how to read the data from console using printf and scanf functions. All those basic details are covered in a separate video and I'm gonna leave that video link in the description, so please go ahead and look at it before you actually start coding or writing this program. So we all know about prime numbers, right? So basically for those who don't know prime numbers, it's like basically prime numbers are the numbers which are divisible only by itself, the number itself, and 1. Okay, let me tell, it's like 1 and the number itself. The number itself means, let me put comment so that it will be easier. So if you take 2 is divisible by 1, okay, and 2 is divisible by 2. That's it. Same thing with 3. Okay, same thing with 3. 3 is divisible by 1 and is divisible by 3. That's it. So basically it has only 2 factors. It also has 2 factors. If you take 4, it can be divisible by 1 and 2 and 4. So basically it has more than 2 factors. Coming to 5, again it can be only divisible by 1 and 5. Okay, basically any number which has only 2 factors, that is 1 and the number itself, those are prime numbers. So we're going to go and start writing the program. So basically the program is to find a given number. So the user is going to give a number, we are going to store it, enter a number to find out whether it is prime or not, or otherwise simply we can put enter a number, and then we are going to do scanf and read it in number. We did not declare the number, so I'll declare it as number. And for printf and scanf to work, we are supposed to use std.h library and it should be number, right? Number. So now we are supposed to write this logic. So to write the logic, for suppose a user entered like 13, so we need to check, divide this 13 from 1 onwards, okay, because we need to know whether it is divisible by 1 and also 2, 3, 4, 5. And in the process of dividing that number 13 from 1 to 13, okay, we'll try to identify with how many numbers it is being divided perfectly, means 0 is going to come, so it's going to be having 2 factors, so that it will be a prime number. For suppose we'll start dividing 13 by 1, and obviously 1 13s are 13, so we are going to get 0 as the remainder, and again we are going to divide it with 2. It won't be divisible by 2, and then we are going to do it by 3. Okay, again it's not going to be divisible by 3, so again we are going to do it by 4. So likewise we are going to divide it till 13 divided by 13. Obviously here it's going to be divisible by 13. Okay, we are going to get remainder 0. So for us to get the remainder, to identify the remainder, we are going to use modulus. Okay, in our code we are going to use modulus, and here if you carefully see, we're going to start with 1 and end till the number itself. So we are supposed to use loops that will start from 1 and end till the number itself. So I'm going to write the loops, so that for int I is equal to 1. So I'm going to declare int I because I don't know, my compiler, my program doesn't know what is I. So I equal to 1, and I need to go till I less than or equal to the number itself, right? So I'm going to put the number and I plus plus if Okay, if that number here, because the top always the numerator is 13, so number not here, we need to get the remainder, right? So for that I'm going to use modulus, and it's the iterator. If it is equal to 0, if my remainder is 0, that means it is divisible, right? So what I'm going to do is I'm going to increment a variable. So I'm going to take a variable called count, and I'll initialize it to 0. So what happens is whenever it is divisible by that number, okay, basically it has it's a factor, let's say, then my count will be incremented. So by the time my loop is completely done, my count value should be equal to 2. It should be equal to 2 for my number to be prime. So if the count is equal to 2, I'm going to simply print prime number. Okay, and I'm going to put new line, else if it is not, then simply I'm going to put what? It's not a prime number, not a prime number, not a prime number. So before running our program, what we're going to do is we are gonna actually evaluate our program. Okay, how are we going to do? I'm going to remove this. We're going to take example of 6 first. Okay, so according to our program, so our I will go from 1 to the number itself. So 1 to 6, my loop will go from 1 to 6. So initially my I equal to 1. Okay, and 6 divided by 1, basically here modulus, we'll put modulus only. 1 is a remainder 0, yes, true. So my count will be incremented, and my count equal to, now it is 1, my count is 1. And again, next time what happens, I will be incremented, it's gonna be 2. I'm gonna do it 2, and what happens, 2 divided by, I mean 6 modulus 2, what happens? Obviously the remainder is 0, so my count will be incremented, it's going to be 2. Now again I equal to 3. Okay, and 3 again, this is also true, and 3 to 6, obviously again my count will be 3, and this 3. Okay, now again it's going to be 4, my I will be 4. Okay, so here what happens, 2 2, so it's going to come 1.5, so it's false, so my count will not be incremented, so I'm going to put it as false. And again my I is going to be 5, and again this is also false because the remainder won't be 0, and then my I is equal to 6, this is true, and my count plus count equal to 4. So by the time this loop is finished, my count is 4, and I'm checking for count equal to 2, hence 6 is not a prime number. Same thing if you take 5. Okay, we'll check the example with 5. If you take 5, so here all my 6 will become 5 5 5, otherwise we'll remove it, we'll write freshly. Okay, I equal to 1, 5 percentile 1, which is true, so obviously my count equal to 1. Next my I will become 2, and 5 divided by 2, no, it's false, it's not divisible. And then it is 3, it's divisible, no, it's false. And then 4, is it divisible, no, false. And then it's 5, oh sorry, this is 4, right? Yes. And now this is 5, so 5 percentile 5, obviously it is 0, so my count will be incremented, and then okay, and then simply count, my count is 2. So once my loop is done, my count will be 2, obviously 5 is a prime number. So my logic looks pretty strong or solid, and let's gonna compile it and run it. Okay, I'm gonna go open the terminal, push it to right, and compile it, prime number. I'm gonna output it to prime number. Okay, no errors, nothing. So we're good to go and run the program. Enter a number. I'll give 5. 5 is a prime number. And enter 6. 6 is not a prime. And I'm gonna enter 48. It's not a prime number. I'll give 41. It's a prime number. It's working fine. Thanks for watching the video. If you like the video, please like the video and share and subscribe so that it will be motivating for me to make more similar content.